Hi, welcome to my YouTube channel 3D Multimedia. This video is about how to create a word cloud using TF-IDF, that is term frequency hyphen inverse document frequency. So what is a word cloud? Word cloud is a graphical representation used to illustrate textual data. The words in the word cloud, they appear in different sizes and different colors. So the text which looks larger and more brighter or bolder are the ones that appear more often in the text. The main purpose of the word cloud is to quickly see which words are most important or common in a text. So this helps to understand the main topic or theme of the writing based on the word frequency. This is a sample formation of the word cloud. So the more frequently a word appears in the text, the larger and the more prominent it appears in the cloud. So in this word cloud, if you see, there are some words which are very larger and there are some words which are very smaller. So the words which are very larger, right? So they occur more frequently in that particular sentence or document, and the words or the text which looks very smaller are the ones occur very less in the particular document. So words are typically displayed in a random arrangement or arranged according to their importance rather than in a structured layout. So word clouds are used in different areas like summarizing text, keyword analysis, sentiment analysis, and discovering patterns. To make a word cloud, we take the text and count how many times each word appears. Then we will use a special tool to create the visual cloud where words that show up a lot are bigger and more noticeable. We can change the colors and layouts to make the word cloud look interesting and meaningful. So let's see an example here. So I have two sentences about animals. So in sentence 1, we have the brown fox jumps over the lazy dog, and in sentence 2, the quick brown fox catches the slow mouse. So you can see the common terms here. The and brown is common here, fox is common here. Apart from that, the other words are different from each other. Okay, so we create a document term matrix. A document term matrix is nothing but it's a collection of rows and columns along with values. So we have different words in both the sentences here, and then we give the number of frequency, that is number of times the word occurs in that particular document. So you can see here under the term the, right, the we have given 2 times and the we have given only 1 time in sentence 2. You can see here the appears 2 times even if it's uppercase or lowercase in the particular document, and the zero all indicates that those words are not available in that particular sentence or in the document. Okay, so now we will assume the IDF. Okay, that is any word that appears a more number of times will be considered as low IDF, that is inverse document frequency, and the word that appears in both the sentences can be considered as medium IDF, and those words which appear in sentence 1 are not appearing in sentence 2, and those words appearing in sentence 2 not appearing in sentence 1 are likely uncommon, right? So due to being specific, we consider this as high IDF. Okay, so here we have the number of frequency or number of occurrences of the particular word, and along with that we have IDF, which provides as low, medium, high. So here we have computed the TF-IDF based on the number of occurrences and the IDF. So in sentence 1, let's see the analysis. The high TF-IDF are the words like jumps, over, lazy, and dog. All appear only once. So a term frequency is 1 and are likely uncommon terms in this context. So it is high DF because they don't appear in the sentence 2, right? So this term specifically describe the action of the fox in this sentence. So when you come for the medium TF-IDF, brown and fox, they appear once, TF equal to 1, and are assumed to have a medium IDF based on our limited sample. So low TF-IDF are the words that appears twice, but it's a very common word. So it's a low IDF. Similarly, in sentence 2, the analysis, high TF-IDF, quick, catches, slow, and mouse all appear once. So they are considered as high IDF. And in medium TF-IDF, the brown and fox TF equal to 1, okay, have a medium IDF as before, because the brown and fox, they appear in both the sentences, right? So we consider this as a medium IDF. Okay, but in this sentence, brown and fox, okay, in this particular sentence too, it appears only once. That's why we have given TF equal to 1. So similarly for low TF-IDF, the appears only once and remains a common word. So let us now create the word cloud using TF-IDF in Python using Google Colab. So I'm going to import two main libraries to create this word cloud. So first one is scikit-learn and next one is word cloud. So scikit-learn is nothing but it's a machine learning library in Python. Actually, this library provides modules for text processing such as TF-IDF vectorizer, and then we will install word cloud. It's a simple tool in Python for creating word clouds from text. Okay, so here this TF-IDF vectorizer is nothing but it's like a pre-processing step. So let us import TF-IDF vectorizer from the sklearn.feature underscore extraction. So this particular class in scikit-learn converts a collection of raw documents into a matrix of TF-IDF features. That is, it will take a particular text and give its corresponding frequency, and this will be in a matrix format having rows and columns. Then we'll import word cloud from word cloud module, and then we'll import the pyplot module from the matplotlib library and alias it as PLT. So let us now create some sample sentences and store it under documents. So here I have 6 sentences related to NLP, and now I'm going to initialize the TF-IDF vectorizer. So this function has to be initialized so that we can finally create a word cloud. So here this TF-IDF vectorizer is nothing but it will convert a collection of text document into a matrix of TF-IDF features. So let us fit the vectorizer on the documents and transform the documents into TF-IDF matrix. So vectorizer dot fit underscore transform of these documents. These documents are nothing but which has the collection of these sentences. So each word, okay, the correspondingly the number of frequency will be counted and it will be stored under row and column, right? So that will be in the format of TF-IDF matrix. Actually, the TF-IDF matrix is nothing but it contains numerical representation of text data in a document term matrix format. Okay, so in this format, so each row represents a document and each column represents a word or term. So you will also have a value in each of the cell that indicates the frequency for the aligned particular term. Now let us extract the features, that is nothing but the words. Okay, so you have a particular sentence, right? So from each sentence, each word, like they are the independent, right? So you have to pick each of the word or each of the term and you have to place it inside the document term matrix. So for that, we use this vectorizer dot get underscore feature underscore names underscore out function, and we store it under feature underscore names. Not only this particular function will help us to create the TF-IDF term frequency and IDF inverse document frequency. And now finally we'll create a word cloud. So we have a width of 800 and height of 400, and we want the background to be in white. And finally we will generate from frequencies. So what frequency we got from TF-IDF, then we will also compute TF-IDF also. So based on that, this vectorizer will use this vocabulary to map the terms to their numerical indices, and it will create a word cloud for us. Okay, and now we are going to plot the word cloud. So here we have given the interpolation as bilinear so that we get a good pixel features. So this is the visual representation of the sentences what we gave there, and here the only drawback is we have not done the text pre-processing, right? So let us come back here and you can see that there are some words like documents, and we also have parts of speech. So the documents is a single word, it has to be considered as a single word, right? So if you see in this word cloud, this particular word documents will be given as only document, since it is separated with apostrophe, so it considers document and yes as separate words. Similarly here you have part of speech, right? So you can see here this part of speech in this particular visualization. So you can see here part is here, so similarly you will also find speech. So you can see speech. So actually this part and speech and off is somewhere here. So part of speech has to come as a single word since we have not done any pre-processing. So any word after the hyphen also is considered as a separate word. So if you want them to come as a single word, then we will create a word cloud again by doing the text processing. To involve the pre-processing steps inside this word cloud, we need to import RE, that is a regular expression, and similarly we will import TF-IDF vectorizer and import word cloud and import matplotlib.pyplot as PLT, same like previous one. Okay, then we have the sample documents. I'm storing the sentences under the different name as texts. So let's now write a function to clean the text. So def is nothing but it tells that this is the starting of a function, and then we give a single argument under clean underscore text. So re is used for pattern matching. So re.sub is used to perform the substitution in the text string. Here this regular expression is cap in lowercase a hyphen z or uppercase a hyphen z slash s, that is white space. This particular regular expression matches any character that is not a letter. Okay, so here we have flags equal to re dot ignore case. So this argument actually ignores the match case insensitive. So both the uppercase and lowercase can be considered, and then we try to split the clean text into a list of words and sort the list of words alphabetically, and then we try to join the sorted words back into a single string with the spaces. So this we are going to clean the document. Coming to this for loop. Okay, for text in text, so texts is nothing but we have stored our sentences inside texts. So text is nothing but the single word inside your sentence. So for each word in the particular sentence, okay, we are going to clean the text and store it under cleaned underscore documents. Later on, we will initialize the TF-IDF vectorizer so that we will be able to create the word cloud. So this function, we will initialize it and we will store it under TF-IDF underscore vectorizer variable. Later on, we have to fit the vectorizer, okay, on the clean documents. So sentences which we had under the texts, right? Okay, under that list. So we'll fit that vectorizer towards that. So that this vectorizer can extract the TF-IDF features. Okay, and we store it under matrix. So now we will extract the features same like what we did previously. So TF-IDF underscore vectorizer dot get underscore feature underscore names out. So wherever we had those words in that sentences, we tried to calculate the number of frequency of the particular word, right? So we placed it under the row and column in that particular document matrix, right? So for each word, we tried to extract the feature and we gave it as a numerical representation there. Now we will create a word cloud. So with a width of 800 and height of this one. And now we are going to generate the word cloud. For that, so coming to this part, for I in range, length of feature underscore names, this particular loop will go over each index I in the range of length of feature name. If there's a particular word, so it will go one by one in that, and then it creates a dictionary here where each word in this feature name is associated with its TF-IDF score, and then we do the sum of all the TF-IDF for each word, and then we sum it again, and this A1 of I will convert the row vector to one dimensional array. So we can choose the ith element from it. So once we have extracted the feature names, that is the extracted the particular words from the sentences, and we found the number of occurrences or number of frequency of those TF and IDF and TF IDF, and then now we can plot this word cloud. Here the interpolation we give it bilinear so that we get a good pixel intensities. So why did we create a word cloud again? To make sure that this particular words, you can see here, like this part of speech I wanted as a single word, and documents also I wanted this particular TF-IDF to consider as a single word. So since we have done this cleaning here or the text processing, so now you can see here documents has been considered as a single word, and similarly you will also have the parts of speech here has been considered as a single word. So if you have liked this video, don't forget to subscribe my YouTube channel 3D Multimedia. Thank you.